Okay, then with no further ado, let's start. First of all, thank you, Christian, for setting the stage. Thank you for all coming in the stream. Yeah, thank you for being here. If you have any questions, I'm currently not. Let me check this out. If there are any questions in the stream, this might be interesting. I am trying to my best to Christian is to answer the questions, but it might be that I'm currently concerned elsewhere in the presentation. Okay, so then let us wait for a second till the screen catches up, that I get okay that the presentation is there. Should be just some more seconds. Okay, for the audience in the room, you can, if you want, scan this. This link brings you to the examples, no, to the slides. So yeah, it brings you to the slides. So if you want, you can scroll the Markdown file along. If not, that's also okay. So, okay. So, short introduction. The name Frank Reimann. I'm a software engineer at Jambit. GitHub handle, and like I said, you can, if you want, watch along the slides. Who am I? I'm more or less developing software since 2003. If you count TI, Texas Instruments, 83, probably even earlier. So privately or in companies, as freelancer, I worked a decent chunk of tech stacks from top to bottom and bottom to top. I worked for public German television, ARD. I worked for Check24 here in Leipzig for the post-booking engine. Shout out to Michael and Carsten. Currently, I'm employed, like I said, at Jambit, and I'm doing a lot of various things, mainly full stack architecture, and in I think the last 1.5 years, I'm doing more and more AI stuff. Yes, I would say I'm collecting tech skills like others collect Pokemon. So if you want, you can look it up on roadmap.sh. But for this presentation, I think what's more important to know about me is that I'm doing front-end stuff with jQuery since 2011 till 2017. I worked with React 2018, starting on and off. I think I had Backbone, all the frameworks sometime around. I tried out some things with them, and I think earlier I did more PHP, but yeah, it contains front end too, right? So it's more like vanilla. What was vanilla HTML? Yeah. Also, I worked in some Angular projects, some Vue, some Java projects which are relevant for the talk, and my current favorite is Svelte 5 because I really like the new Runes API, which feels coming from older Svelte versions and coming from React really good for me, actually. I can say for sure it's more like smaller projects, not too much front-end involved, but what Svelte 5 brings to the table in terms of automatic compiling, speed and whatnot, I really like it. But today we're here back for React, and if you want, that's something that we can do later in the live coding session. You can try it out for yourself. So you could, for example, like I said, if you have a notebook with you, you can simply npm stag it, the example, npm I, npm run, and you have this example, or one of the two examples running, which uses React with the approach I'm showing you today. So, other than that, our agenda for today will be, okay, we will we will make the problem statement, something like a hypothesis, yeah. We show how different frameworks actually solve this problem. We show how our attempt also tries to solve this problem and what benefits this brings to the table. Then in the later stage of the talk we are going through some examples, really small entry-level examples, how to get started. For example, if you feel lucky, right, to say, I have an enterprise architecture, and I want to use this project, somebody put it together with AI. Yes, be my guest. And after presentation, like I said, we can do the live coding at my laptop. You can come by and just tell me what you would like to try, or we can do it with yours, maybe with Chris' notebook, and see how this feels for you, right? Okay, so anyhow, let's start with a problem. And the problem is a problem that I'm not the first one saying this. It's that React doesn't scale. And first of all, in the room, who's worked with React? Okay, who likes React as it's his favorite framework? Okay, great, thank you. Okay, who likes React hooks? Okay, that's something maybe we can talk later. Why? I'm really, yes. I must say, after years of React development, I'm not so much a fan of hooks. Because, and that's the thing where we're coming to, I think hooks are really hard, and React itself is really coupling the code base together however it can. And this is tonight's hypothesis or thesis, let's call it more the idea behind the framework, that coupling is actually the root cause and dependency injection is the proven solution for the opposite of coupling, decoupling. Okay, for example, we have this example here. Say we have a user profile, yeah, and this is more or less a hello world example from the React website. We have something like some use effect hook. We have some fetch user thing, whatever, maybe fetch notifications. We have everything coupled in a view, essentially, right? So we have a business logic. We have something that in other languages would be something like a repository or a port and adapter calling an API. This is simply just put in a view, right? And so, and if this thing grows, we have something like that. We have maybe somebody came by and said, I need some props that I want to inject into this functional component. Maybe somebody was like, this use effect hook inside of my user profile, this is getting really long, let's put it in a hook, right? So, and then the next one added another use effect, and the next one just, let's put it in a hook again. And maybe you had a problem in this hook to fetch something, and you put a hook in a hook, right? So the result is something that React doesn't provide you with some architecture. They're more or less saying, we are so easy, this is so easy, and it's great for small applications, but if you want to scale, a lot of solutions for problems, I believe, are self-made, were invented over the course of the last 6-7 years. I'm not sure when React came out. Yeah. Okay, so let's look at other solutions. I say backend solved this, but also Angular solved this, but let's first look at Spring Boot. Those of you who are familiar with Spring Boot comes with dependency injection auto-wiring directly around the corner. So this is great. I would love to see my mouse. Okay, sadly, I can highlight it on my presentation view. You can see it, but we have a REST controller or a service which simply says, okay, or has an annotation, right? The user controller has an annotation, REST controller. And with such annotations, Spring Boot marks parts of the software that need certain metacode manipulation, right? And for example, we have this user service which has a add auto-wired assigned. And this means if this thing gets started, if the class gets initialized, the auto-wiring mechanism in the background just looks, oh, what's the interface, what they require, okay, do I have an implementation for that? They build up a dependency tree and then they put this thing from leaf to top, they put it together and the application is running. And this is fully decoupled, right? This is fully decoupled code, so effectively the opposite of React. So Angular, the same thing, similar. The thing is, for example, just one thing, if you're familiar with, for example, Spring Boot, they have something in Java called type erasure. For that, they have the problem that generics aren't there at runtime, and therefore they are, I think they are using reflection, if I'm not mistaken. You have trouble with generic interfaces, so they have additional annotations for not only AutoWire, but a lot of different annotations for certain use cases. But we will focus actually currently on the AutoWire, and we have some benefit. We are using TypeScript, but we'll come to that. So we have a little bit more functionality with less coding. Okay, and now here's the post solution. You can see, for example, and that is, let me see if I can. Oh, great. You see my mouse cursor, I don't see it. Let's go back for a second. Give me, that's the reason why. Great, mouse cursor. When we look at this, we have, down here, we have this user service. It's a class that's functioning React code, by the way, already. That says, okay, we have this user service interface, which is implements the interface, and we have this class. And up here we have the user profile, a functional component that we can see because it returns React or JSX notation, where we simply say inject user service interface. So we have a marker interface, right? We have simply a generic T, inject T, which is a marker interface. And this is actually almost it, what I can tell you, because that's the core of the idea. So, but luckily we are not finished with the talk. So, what are what I think key advantages of this? Because that's really a huge deal. Normally you would put, if you have any kind of business logic in your front end, you would create a hook, or you would create maybe a state store, maybe Redux, Zustand.js, something like that. And if you wanted to isolate it anyway, but still you would be having some way of coupling to React in a lot of cases, right? Or in case of Redux, either you have some really convoluted utility frameworks, or you have to do the Redux stuff manually. Okay, I think Angular did it really good. They have I think a better Redux implementation, if I'm not mistaken. But the core idea is, here in React, you put a lot of time, a lot of logic in a hook, and there it is. It just stays in hook, and you have problems with testing and what's not. And let's discuss this from an architectural perspective. Just show of hands, who knows Solid, the Solid principle? Yeah, okay. Okay. So I put an emphasis on the D, yeah, dependency inversion, because this is actually what our framework is solving, and by solving this, it makes way for all the other options that you as a developer can additionally use, for example, single responsibility, right? Or open-close principle, because what we provide is simply a mechanism that you can use classes instead of hooks. And those classes can be structured however you want. You can still write spaghetti code, but you can actually use proven software engineering patterns and use, for example, single responsibility, open close, like I said. So, and down in the example, I made some comments about what I think violates those principles in typical React code. and no. Why it's no, I'm sorry, that was the wrong one. Okay, so, and here comes the magic, it's simply compile time transformations. So like I said, the marker interface, the inject that you put, you write the code on top, you write user profile, blah, 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 inject, and TDI2, it's called here still, direct service injection, replaces it with hooks, but here's the kicker, it replaces the hooks not at design time, but at compile time. So you can write decoupled code. At compile time, it does the same thing like Spring Boot. It creates a dependency tree and resolves it and injects the code tokens. Like you see, for example, there's the user service down in the lower example. The user service is here is a string, and this is what it does. It just takes what it finds that the inject marker interface has. If it's a generic, it replaces with a string t, for example. So it just generates a string and registers this implementation behind this in its own lookup table. Right. And with that, for example, testing to a certain degree becomes trivial, at least unit testing or something like that, because you simply can create some class. Yeah, you simply can say, okay, I don't have this implementation here because I would inject it, but you can simply say, okay, this React function component, I just create a class of this interface ad hoc for testing. Great. And what's also nice, this is something I worked on yesterday and today, but yeah, someday you have to work on the presentation too, right? So I'm in the process of creating something similar of a testing framework, a really small testing framework which allows to test things like with Java Spring Boot. So if you're aware of, for example, the mockbean or something like in Java, that's essentially it, right? I can show you later what the state is. I will not show it in here because that's another thing. First thing, let's create dependency injection framework. Then think of a testing framework, right? We can invent everything. And what I believe are the key benefits, we have, for one, we have less props, right? That's problem if you have a lot of props drilling, to, for example, not use hooks for certain things. Then you have sometimes a cascade of prop drilling, or for somebody wants to add a layer, then he has to add prop drilling to this intermediate layer. Like I said in the previous slide, you probably have easier testing. You have this flexibility through this decoupling, yeah, that you don't have to touch so much code. For example, if you previously had a hook and you say, oh, I want to replace this hook with something, well, you have to touch every file that imports this hook, right? And maybe you want to separate this hook functionality, like I said earlier, solid principles, separate these concerns, right? You want to split the hook, then you would have two hooks that are partially there. But what you actually only need are those classes and those interfaces, and you could say, okay, I want this one interface or both interfaces, or I want to combine interfaces, and at best, I'm not sure at the current moment, but at best it would wire you something together from the existing classes. Right? So, and best of all, it uses familiar patterns. It's nothing that we invented per se new. It is just looking at what others did already and how we could do it with React. That's the core idea. Okay, so let's look again at React code. I showed you the more the evolving problem some slides earlier. This is some more code about this evolving problem, right? So we can all see that, for example, there could be a use user hook, which has, I don't know how many hooks it has, and get notifications hook and whatever, and those are all tight coupled. And if you think about it, what a hook in a hook is, if you would implement it with classes, would be a static class with a static global store. I'm not sure. So at least looking from this perspective, this does feel off somehow, right? So you wouldn't implement it in a different language. Sure, those developers at the time had some good ideas about the problem they wanted to solve, but I have the feeling that over the time other problems emerged that were more or less patched and tried to find workarounds for, instead of solving the actual problem. Okay, yes, and if we compare it, this thing here now, this is not too different, right? We simply say in the call, in the function argument list, we simply say inject instead of tight couple and inject some interface instead of tight coupling the hook itself, right? That is so from a programming perspective or from programming, it's simply, oh, I have this button, yeah, I could use a hook, but nobody would couple a hook. But now you're decoupling this thing. So you could say, okay, you know what? For this button, I need this interface. I'll just do it because it's still only a change in exactly this button, right? Everywhere where this button is used, you don't have to make any changes, for example. So it's really, really simple and it's really straightforward. I don't tell you, yeah, use a lot of services in the button component. But that shows how you could do it. For example, logging, or maybe you have sometimes you have some metrics that you will have some click metrics. Yeah, you would have a hook or something, some signal to the outside, and this is tight coupling then your metrics. So matrix, not your metrics. So as an example, this was something that I really disliked to implement in the code base because it put concerns together, and I was like, that's not a good thing, at least from my perspective. So, okay, now that we know how that the code looks quite similar actually, right? Let's see how this works. We simply have a white plugin. As of now, we have a white plugin, but feel free to provide a roller plugin or whatever. I also only fiddled it together with the chatbot, so it was working. I'm okay. Let's go. It was a little longer, not only one core. But so also we are using Valtio under the hood. I don't know, Valtio is something that's similarly to MobX. Valtio makes our classes that we inject reactive by wrapping them in a proxy. That's done automatically. You write the classes, you say, oh, this class has a state, this class has functions, and as soon as you use this via inject, this class gets injected and wrapped in the proxy, and then your class is suddenly reactive. That's really, really nice. So I was looking like, okay, React class reactivity, and okay, and then this came up. So this was the current decision. If you find out that any of those building blocks is not good in any situation, I'm not opinionated on that. It's only Valtio is currently the thing that works, right, for the use case. So if you have something better, just tell me. Okay, the other thing, TypeScript. Yes, we are simply reusing the interfaces of TypeScript. But what we are doing, we are not using and we are using decorators. But other than, for example, frameworks, dependency injection frameworks that are already around, TS Syringe and TS probably Inject, they are doing it at runtime. And at runtime, we don't have type information anymore. And to a certain degree. But the good thing, we are using the white plugin is an AST transformer. So we are having the full capabilities of the TypeScript language. Yeah. So if you want to get started with this project, like I said, we have those examples. I would suggest just check them out. But if you wanted to add them to your code base, like I said, you have an enterprise application. You're like, boss, yesterday, this madman, he said use classes in React. And your boss, that's a really good idea. Then please go on. Okay, so you only have to install those 3 packages. I already put the DI core and the white plugin in separate packages. Then you have to configure your white. This is what you do in the second step. You just say, okay, use the DI enhanced plugin. In the third step, you create your first class for the, yeah. Okay. Like in this example, you create an interface. You see a class, my service, with the annotation at service, right? And then you can use it. Also, we have another, like I said, inject is a marker interface, but also a decorator. So if you wanted to, my service, you could create a constructor and do the same thing there. You could say add inject, right? In the examples, I can show you later, add inject, and then you have this transitive dependency resolution. Right? So from here on out, as soon as you use this, as soon as you use your first class, you can simply develop with classes. And then you can use it in components, right? You say, okay, inject my interface, and the auto-wiring mechanism provides this for you. There are some smaller nuisances. There's currently no functioning ESLint plugin, so your React code says, oh no, there is a missing service. Yeah, but those are things that then another plugin can fix in the future, if this gets traction, right? This is not make or die? I don't know. Okay, so, okay, that's actually about it. First of all, who would be ready to try this? Who would be saying, okay, I'm really interested in this because it maybe solves actually some problems of mine? Okay. Who's more like, nah, I'm skeptical? Okay. Who did I lose? Who's lost a bit? Okay. you can raise your hand multiple times. Totally fine. Okay. Okay. Well, like I said, those we can try directly out in a few minutes. Let's go on to the Q&A then.